All right, so welcome. Let's jump into some stylized fire. So uh, uh, I know that you probably know a bit about shaders and sort of what they're meant to do, but uh, going through the whole sort of shader language stuff and talking about like GLSL or HLSL is definitely way beyond the scope of anything that I sort of want to do in this sort of workshop setting. So uh, that's why we're going to use a shader graph. It's relatively easy. I know that's any sort of node-based tool that you've used before, whether it's for programming, whether it's for something like Shader Graph or Shader Graph itself. It's a lot easier to manage, and you can do a lot of the same things. Unity does have some default shaders, but they are not as useful if you need something that is very custom. The default ones, they let you change the color and use different maps for things like normal and things like specular and metalness and all that kind of stuff. But if we need something custom, if we want something sort of custom and interesting, then that's why that's what we need to use our own shaders for, and that's something that Shader Graph lets us do without having to actually program for the GPU. So the biggest sort of starting things here is make sure you have everything sort of set up. So to use Shader Graph, you got to have Unity 2019 or later. You've got to be using one of their sort of newer render pipelines, so the HDRP or the URP. The starter project that's on GitHub, I used 2020.3.0 for that one, but of course, if you have a version that's later, it should open up and everything should work just fine. And that one uses the universal render pipeline. If you're not entirely sure that Shader Graph is sort of loaded, then you can go check the package manager for that. So you can just check and make sure that that package is there. If you load up an HDRP or a URP scene, it should already be on there. And the starter project, it's already loaded. So we're going to create a couple things to start with. We're going to create an unlit graph, and we're also going to create a material for that graph to use, and then just a quad, just a simple a simple polygon, basically that's 4 vertices to throw this onto. So that's sort of the first few steps. So we're going to create an unlit graph, we're going to create a material, and then that quad, and we'll just sort of get it set up so that we can mess around with the graph and see the results on the quad as we go. So I do have Unity open here. Say is this one here. So scene wise, I have this main scene open right now, but the scene that we want to use is the starter scene. So this one doesn't have anything else in it other than the main camera, a directional light, and a little bit of post-processing. So in here, I'm going to create the quad first. So I'm just going to right click in the hierarchy, and I'm going to create 3D object and go down to quad. And we don't really have to worry about sort of naming this anything special. It's just going to be something that we can put our material on that we create in a second. So to start with, the quad, of course, is just our square here. It's only one-sided, which is fine, and it should be pretty much in our game view. We might want to move the camera or move the quad around a little bit so it gets a little bit bigger, but for now, this is probably fine. We'll probably mostly be looking at it in the scene view for the moment anyway. So with the quad, let's add a material. So in the in the project tab, I have the assets folder, and I've created a materials folder already. And this has some of the finished materials in them, the ones that use the shaders that we're going to make today. So I'm going to make a simple material here, and I'll probably just name it fire or something. We're going to change the shader that this material uses in a second. But for the moment, I'm going to take the shader and I'm going to drag it onto the quad so that it uses that, or grab the material and put it onto the quad so that it uses that material. And the last piece was to make the shader. So in the shaders folder, I'm going to right click, create, and we want to go to shader, universal render pipeline, unlit shader graph. So we want a shader graph that is unlit. So there's a couple of menus to go through to get that. So again, that was shader, that was create, shader, universal render pipeline, unlit graph, or unlit shader graph. And I'm just going to name this fire as well. Now this shader is currently empty. There's not really anything going on. It has sort of the default color and stuff like that. But for our material, so if I go back to my fire material, I can change the shader that it's using up here at the very top. I can change this to shader graphs, and I should see my fire one in there that I just created. So that's the setup that we need to do. Create the material, create the shader, make sure that the material is set to our shader that we just created, and then make sure that our material is on the quad. So now we're ready to go. Now we're ready to sort of mess around with some of this stuff. And definitely feel free to ask me any questions or stop me anytime if you need something, if you need me to mention something again. All right, so with our shader, we can double click on it, and it brings up the shader graph. Now, in a recent version of Unity, I think it was one of the 2020 versions, they changed the look of the master node a little bit. So it's separated into two sections. There's a vertex section and there's a fragment section. And this sort of better matches what you would see in an actual shader program, some actual code that you would actually write for shaders. There's usually a vertex shader and a fragment shader. The fragment is all we have to worry about because this is going to have the color and the alpha or the opacity. Now, currently it just has the color because our surface is set to opaque. Now we want to have a transparent surface. So up in this sort of universal settings here on surface, we can change this to transparent, and we see that the alpha shows up here. So that would be sort of the transparency of this particular shader. So that's what we want to make sure we have. We have the fragment that has the color and the alpha, and that's actually all we need. We're going to do a bunch of work with other nodes, but this is basically all we need for our master node's output. So just a quick rundown of some of this stuff. If you haven't used a sort of nodal base editor before, anything on the left-hand side is an input, and typically there are default values for those as well. And then with the inputs, you can plug in outputs to change what those what those values do. So if we want to change the color, I could create a color node and plug that in to the base color here, for example. So there's lots of sort of lines that are going to go everywhere. It's going to look kind of like a flow chart once we get a whole bunch of stuff in here. Whenever you make a change to your shader, you do need to save it. So up here in the upper left, you'll see a save asset. It won't sort of save automatically as you change things. So make sure that you do save, especially if you want to see what the results are on our quad. All right, I don't want to switch between the slides and Unity a whole lot. I have a few things in here at the beginning that are going to sort of mention some of the stuff that I just said, but I want to sort of give you some of the basics and then jump in and just do a bunch of live stuff. And then we'll jump back a little bit later on. So the slides are more meant for sort of a guide to the live stuff that I'm actually doing. So I'm not going to flip back and forth a lot. Now, the thing that we're actually doing here, the way that we're going to get this fire stuff to work is UV distortion. And this is one of these concepts that it can take a little bit of time to grasp. So UV coordinates, they're just used to map a 2D image, like a texture, onto a surface. So any texture that you bring into Unity is mapped to a square in UV space, and that square looks like this. So it's just 0 to 1 in both dimensions, but they're usually represented by colors. So 0, 0 down here in the lower left, that is 0 red, 0 green, which is black. And then up in the opposite corner, it's 1, 1, which is full red, full green, which is yellow. And then you have your green here and your red down in the opposite corner. So it's just mapped, whatever texture you have, it's just mapped to a 0 to 1, 0 to 1 square. That's it. And so the concept that we're going to use is distorting these coordinates to give us an interesting effect. That's the whole basis of the stylized fire that we're going to do today, and then the Diablo style shader in part 2, and then we'll sort of mess around with some particle system stuff later on that sort of comes into some of this UV stuff as well in the third part of the workshop. So any texture you bring in has this mapping. So if we can adjust these UV coordinates in a way that looks like some fire, then we'll be able to actually do some sort of realistic stuff. So basically, I want to show an example of a UV distortion. We're going to use a twirl node, and we're actually going to use one of the textures that I've included in the project. So let's go back to Unity. To create a node in our graph, I'm going to right click and I'm going to say create node, and we're going to create a twirl node. So it should be under, if you sort of start typing in the search, start typing twirl, you should see it there. It's under its UV twirl. All right. So this takes that standard UV cube and it distorts it. So it does this sort of spiral pattern. So let's bring in a texture so we can see how that texture's UVs, when they change what the texture actually looks like. So I'm going to create another node and I'm going to start typing in texture. Now the texture we want is input texture, and we want sample texture 2D. So this lets us bring in a texture from outside. Now there's no texture in here right now. We need to select one of those. But notice what the inputs are. It has a UV input. So we're going to take the output of the twirl and put it into the UV of the texture and see how that changes. So let's load a texture first. So right here in this sort of default input, we can click the little circle with a dot in it, and it brings up a list of all these textures. And a whole bunch of these are ones that I've put into this project that we can mess around with. The one that I want today, and the one that's going to help us to get our stylized fire, is this RiME texture. It's this one that's sort of mostly blue, but has this sort of red and green hump. So I'm going to select that one. I'm just going to double click here, and we can see that texture here. Now, if I plug the twirl in from the output of the twirl into the UV input for the texture, we can see how now it's distorted it. So that's what I mean by UV distortion. Now, we're not going to use a twirl, but we are going to make our own distortion. So there's really two parts to what we're going to talk about today. There's the distortion itself, the custom distortion that we're going to make. And then there's the sample, and then there's the sort of dealing with the texture. This texture is not going to make a very good looking fire, green, red, and then blue. So we're going to take this texture and we're going to unpack it. I made this texture in a very specific way. So we're going to unpack this texture and then change the colors to get our final output. So that's sort of the two parts: create the distortion, deal with the texture. So we are going to need the texture later, but we don't need this twirl. So if you select the twirl and you press delete, then it'll go away. So we're not going to need that at the moment. And the texture we're actually not going to need until a little bit later, so we can sort of put it off to the side. One of the most important nodes for us is the time node. This is going to let us do things over time. So I'm going to right click, I'm going to say create node, and I'm going to start typing time, and it's input basic time. Now it has a bunch of outputs. The only one we're going to use is the first one. That's just sort of regular time, but it has other things like sine time and cosine time that sort of oscillate back and forth. You can use those to do some really cool stuff as well, but the only one we need right now is time. The next node that I want is one of our noise textures. Now I've included some noise textures with the project, but we're going to just use one of the built-in noise generation that Unity can do for this part. The other noises are for part 2 when we mess around with some of those. But for now, I'm going to create a new node, and I'm going to start typing in Voronoi. So VOR, and you can see procedural noise Voronoi. And this is sort of a cellular noise. So it has these little sort of cell-looking things in them, and we're going to mess around with those. But in the end, this is something that we're going to distort. Not in that twirl way, but we're just going to make it scroll. So it's going to look like it's sort of moving up. That's our sort of main point here. Because if you look at the if you look at the inputs, we've got a UV input, so we can distort the UVs of this texture. And that's exactly what we're going to do in a second. The other inputs here are things like how regular these sort of cells are, so we can have it like as an actual grid or have them more distorted. And then the cell density sort of gives you like a zoom type thing here. So we'll sort of give it sort of a reasonable value. These are things that we can just adjust later. Between our time and our Voronoi, we're going to put a tiling and offset node. This is our if you start typing in tile, you'll see UV, tiling, and offset. This is our initial distortion. This is going to help us create our overall distortion that we're going to use on the actual texture. So I'm going to take time, the first output of time, and I'm going to put that into offset. Notice how the UV changes to all yellow. Can't really tell what's going on. Definitely not like the twirl node. I'm going to take the output of the tiling and offset and plug that into the input UV on our noise. And now you can see what this tiling and offset is doing. It's scrolling the texture. And this is just one that's generated by Unity. It's not an actual texture that I have. So we get this sort of nice, these sort of cells sort of moving, in this case, down and to the left. So that's one of the key aspects here. We're going to get two of these Voronoi noise nodes, and they're going to be scrolling sort of together, one of them a little bit faster than the other, to create an interesting looking effect. So this scrolling is something that's going to be important in this shader and in the Diablo one that I make in part 2. Now, right now, there's no way to control how fast it moves. This is how fast it moves, and there's no way to control the direction either. It's always just going to go this sort of down and to the left. So in between the time and the tiling and offset, we're going to do a multiplication. So I'm going to disconnect this node here. So now we get our static Voronoi here. And I'm going to create a new node called multiply. So if we were writing actual shader code, it would just be a multiply. It would just be a star in our code. But of course, because we have this sort of graph function, yes, it takes up a whole sort of node, and we got to put inputs and outputs and all that stuff to it. I'm going to take time, and I'm going to plug it into one of the inputs for the multiply. And then I'm going to create a float. So I'm going to do a new node again. I'm going to say float. Spell it right here. Yep. So this is just a single number. And I'm going to plug that into the second output, or the second input. Right now, the float is 0. So I'm taking time, multiplying it by 0, and getting an output. Well, let's put this output into the offset of the tiling and offset node. Nothing happens. But if I take the number here in the float and I increase it, then I start seeing it move. And I can have this move fast or slow based on the value that's in that float. So that's how I can control the speed of the offset. So now I can have it move as fast as I want in this particular sort of one direction. So I'm just going to change this to 1. We'll sort of keep it here for now, but we'll change that later. If you change the sign here, let's say I want to do let's say I say -1, then it just moves in the other direction. Ultimately, we want this to move up, not like up and to the right or up and to the left or whatever. We just want it to move up. And you'll see why once we sort of start getting more into some of the fire look. So a negative number here is probably what we want, because that's at least sort of moving up. It's still moving to the right, but it's at least moving up. The reason why it's moving to the right is that the offset is 2 values. If I disconnect the multiply here, you see that the offset has an X and a Y. So as soon as I plug the multiply in, what happens? It changes both the X and the Y to whatever the value was here. So it changes both of these, which is why I get an angled motion. So if I want to change that, I'm going to create another node, and this is going to be a vector 2. And I'm just going to plug the output of the multiply into the Y input of the vector 2. So this now has 2 outputs, X, which is 0, and Y, which is related to our time. And then I can take the output and put it into the offset. So there's a couple things I have to do to get this sort of scrolling in the right direction. But the big point here is I need a float to multiply by time to control the speed. And then to control the direction, because UV is 2 coordinates, I need to make sure I'm specifying the correct coordinate, whether it's X or Y in our case in this example, to be the one that's actually moving. So that gives us this upward scrolling Voronoi noise. We want 2 of these. And that's relatively easy to do. And in shader graph, we don't have to do a whole lot. Let's take all of this here. You can just box select, and I'm going to do a Control C and then a Control V to paste. Notice how it even keeps the connections. Now this float, I don't want connected to my multiply here. We're going to create a separate float so we can have this moving at a different speed. But time is going to both of them, which is fine. I don't need an extra time node. For the float, let's create a brand new float. I'm going to plug that into our multiply here. And maybe I want this one moving. I think some of the numbers I use, one of them was like -2, and I think I had one moving like -1.5 or something. So these are numbers that you can, of course, mess around with. So just based on this, I can have two separate noise textures moving at different speeds. And that is one of the keys to getting this to look like an actual sort of stylized fire. We might want to change a little bit about the sort of angle offset and stuff here, make these look slightly different. So I might change something, I might change angle offset a little bit, and I might change this one. Let's see, actually, let's do the top one here. I'm going to make this one so it's a little bit bigger. So now we have one of the noise textures is a little bit larger. The other one here has these things a little bit, maybe a little bit more zoomed out, you know, relatively speaking, and they're moving at slightly different speeds. Again, all of these things are adjustable. You can come back and you can spend hours just messing around to get sort of the perfect look for this. The big point is we have these sort of adjustable levers that we can use to mess around with our shader and what the final output's going to look like. Now, we don't have a final output yet, obviously, but I'm sort of anticipating getting to that point by messing around with a couple of these things. So I'm going to box select everything. I'm sort of going to move it over a little bit where we don't have sort of a ton of room over here, and we have a few extra things that we need to do. One of the main key pieces of this shader is the fact that we're going to be adding and multiplying other textures. So for example, I'm going to add these two noise textures together. So how do I do that? All right, so I'm going to take a new node and I'm going to say add. So I'm just going to take the add node, and I'm going to take the output of the Voronoi noise and make sure that they're in slot A and B. And so now I have the added texture. You can think of it as basically a element by element add. We're literally taking whatever the texture value, whatever the texture value is, right, 0 to 255 for a grayscale, and we're just adding them together. So in here, you're going to get a lot of saturated values. But this is relatively complicated. There's actually a lot going on here. So I want to take this add here, and let's plug this in. Let's take the output of this, and let's plug it into the base color of the fragment shader. And then let's save this. So I'm going to save the asset. And let's go back to the scene view. And actually, maybe we can go to the game view. Let me move the camera. Move the camera closer here so we can see it a little bit better. And yeah, so I go into the game view here. There's a little bit of bloom. I have the post-processing and stuff enabled. But if we just watch this, it looks more complex than just two textures sliding over each other. Sometimes you get these really dark spots, but most of the time it's this looks sort of like almost like a tangled web in there. Yeah, it's got some bloom, so it's a little bit of brightness stuff going on, but it kind of looks like this little tangled web, and that's a very interesting effect to use for a lot of different situations. And all it is two Voronoi noise textures sliding across each other. I've just added them together, and then we just have them moving at slightly different speeds, and they have a slightly different size. So this is the power of messing around with adding textures, or in the moment, multiplying textures as well. And the Diablo style shader is based on this too. So yes, this isn't quite our fire, but you might be able to start seeing sort of where the fire is going to start sort of coming from as we sort of add a few more textures or multiply a few more textures into this. So I went back to the shader. And I'm going to disconnect this one. Obviously, this is not what we want, but we're going to be connecting this into other things. So back in the slides, I've gone through sort of a few of these things, talking about time and multiply and add. And then I messed around a little bit with some of the stuff here to show that we want to get this to only move up. So the actual shader itself that we're going to be making is this. We're going to add two noise textures together, and then we're going to multiply that output, which is what we have right now. We're going to multiply that output by a gradient that I've given you. You have this texture available to you, and then we're going to multiply that by an alpha channel, which I've already given you as well. This is just a texture. This is our distortion. So we're going to take that distortion and apply it to the UVs of that blue and red and green texture that we already messed with a little bit. So our distortion is caused by the stuff up here. So that's what we're making first. And we're going to do the multiplications here in just a second. And then the distortion's basically done. And at that point, we just have to unpack some of the RGB texture, mess around with the colors, and then plug everything back in to our shader, and then we're basically done at that point. So just with the capability to do this sort of adding and make sure that they're scrolling, that's probably the most complicated part of this whole thing. The rest of it's just some basic operations that if you were actually coding it up would be like one line. So let's go ahead and finish that out then. So this is the output of that add. So we need two more textures. So I'm going to do the same thing I did when I brought in this sample texture 2D of the sort of the RiME texture here. I'm going to say create node. We're going to do a sample texture 2D. And I want this one to be the gradient. So in the input here, in this red input on the circle with the dot, I'm going to find my RiME gradient. So they all start with RiME. That's the game that's sort of inspired from. So there's a gradient one here, and that looks like this. So based on what the shaders, based on what we're supposed to do, we need a multiply here. So I'm going to create another node. This will be a multiply node. And I'm going to take the output of my add, and I'm going to take the output, the RGBA output of the gradient, and plug that in here. So now we have the gradient multiplied by what the addition was. So what you can see here is that where it's dark, where there's the gradient, it's now dark on the actual output of the multiply. And where it's bright, then it's bright. So we've sort of decreased the overall brightness of this add by putting this gradient in. And this is something to mess around with. This isn't some that we have to use this gradient and it sort of came down from on high that this is what you have to do. It's something to mess around with. I found that this gradient works pretty well. I actually tried a few other gradients when I was messing around with this, and this one seemed to work pretty well for the effect that I wanted. But of course, you have a different effect, you might want to mess around with a different gradient. So I'm going to close the texture here. We don't necessarily need to see the gradient. So there's a little arrow on the texture that lets you sort of close it down. All right, so that's that first multiply. Now we have one more multiply to do with the alpha texture that I mentioned before. So I'm going to create another node. Again, it's a sample texture 2D. And I'm going to do another multiply as well. And the texture I'm going to use for this, I'm going to open up our textures here, is the RiME alpha. So it sort of looks like this, almost like a little spotlight type thing or something shining down. So I'm going to take that one, and the output, the RGBA output of this one is going to go into the multiply, and then the output of this multiply will go into the bottom one here. So you can sort of see what that's done here. In principle, you could combine the gradient and the alpha into one texture if you wanted to, and then not do this twice. But I think it's useful to be able to mess around with two separate ones here and to see how this process evolves from our two noise textures to a gradient to this sort of alpha here. So the alpha texture works pretty well because anything that's black when you multiply is just black. It's just 0. So if you multiply it by anything else, it's just going to be 0. So that's why we have black along the outside here. All right, so this is our result. This is our distortion. Now, it doesn't look like a distortion yet. I'm going to take my base shader and move it away, or my base sort of output and move it over. And I'm going to take this blue texture here, and we're going to move it over a bit because we're going to need it in just a second. Now this doesn't look great, but we're going to take this texture and we're going to add it to the UV. So that's how we're going to get this sort of whole thing sort of working the way that we want. So let me do this. So I'm going to create a node, and it's just going to be a UV node. So this is literally the UV of that quad that we have. So it's just the UV. And I'm going to take this output and I'm going to add it. I'm going to do an add. We're going to add it and this multiply. This isn't quite what we want. You would think that, okay, I can just add the output of our sort of distortion we want and put that into the UV. It's not quite what we want. It's close, but it's not quite. Because remember, the UV, the distortion is in green, red, and essentially the sort of shades in between, from black to yellow, red to green. So this is white. So this isn't going to do anything distortion-wise for us. So there's a couple of steps that we have sort of before we mess around with this. So there's a couple of extra pieces here between the UV and the add that we can do. And we're going to need to do something like this a little bit later as well. So I'm going to create another node called split. So this is the split node, and it's under channel here. So it's a channel split. What this lets you do is this lets you take an input and split it into its components. So for example, we can split this UV into its red, green, blue, and alpha components. Well, the red and the green are the only ones that matter here. So I'm going to create a vector 2, and I'm just going to plug in the red and the green. So now we have a vector 2 that is only the red and green component of this UV. You probably don't necessarily have to do this, but this is important for some stuff that we're going to do later as well, to just understand that I can take this sort of 4 component output and split it into the components that I want, in this case, just the red and the green. All right. So if I plug this one into here, notice how instead of being completely white, this is now sort of has a yellow color to it. That should be somewhat interesting. It's because we've split this out. We're now adding in only the red and the green. So we're adding in only the red and the green channels for this one as well, because this is now a 2-element red and green only, just because this add is red and green only. So there's a couple ways to sort of to get to this point, but we're actually close now. We need to do one more step, but it's between the multiply here and the add here. Red is what is below. We have yellow here, yellow's up in this corner, green's over here. Red is sort of below this image. If we sort of keep going down, we're going to have sort of black over here mostly, and then we're going to have intense red over here. So let me show you another multiply. I think it's a little bit easier to sort of see this. So I'm going to plug this multiply in through here like this, and I'm going to create a float here, and I'm going to send this float to be -1. So notice what that does. That starts bringing stuff in from in this case, it's actually bringing it in from down and to the left, and it's going to bring that color that would normally be outside of the square up into our square. It's not quite what we want. We actually want red. This gives us a lot. This gives us some sort of dark stuff here, although it might work depending on sort of what we do. I think the value for this that I was sort of messing around with was around like 0.6, maybe like 0.65 or something. was what I was sort of messing around with. So not too intense, but sort of somewhat intense. I think this being sort of black coming in here is not what we want. So I'm going to do another vector 2. And we're going to plug this vector 2, or plug the output here of the multiply into the vector 2 here for the y. I'm going to plug this in here to our add. Now I get this sort of red color. So let me explain, let me try to explain a little better what this is actually doing, sort of why we need to do that sort of extra pieces there. So for our multiply, this has 4 outputs. So that's RGBA. When I do a multiply here, I'm multiplying all those outputs by -0.6. So it's going to be very dark. Then I take those 4 outputs and I just take one of them. In this case, it's probably going to be the red channel, but it doesn't really matter. This is just a grayscale anyway. So it's going to take one of those outputs, and it's going to plug that into the add. The first one being 0, and then the output here for the y. So I'm going to grab something in the negative y direction. So I'm grabbing pieces of the texture that are down here. This is useful because this texture, the way this texture is set up, anything outside of the actual texture itself just continues to extend the pixels on the edge. So below this texture, it looks like this. So when I grab some pieces here with this darker red, when I grab something from down here, it'll be mapped to a green color. So whenever you see darker reds up here, you're getting stuff from further down below the texture. This is what the UV distortion is doing for us. Up here in the actual sort of UV here, again, I just split it so that it's only the red and the green that are going in. So it's not a 4 input into the add, it's only a 2 input at most. So if I plug this output of the add into the UV here, this is what you see. Because it's grabbing things, again, it's grabbing stuff from below. If you see red here in the output of a UV, it's grabbing things from further down below. It's grabbing stuff from the sort of negative Y range. And because those pixels just sort of extend all the way down to basically negative infinity, anything you grab from down here will show up here, and I get some of those pixels back up in my actual image. And so that looks a little bit like fire. And of course, changing some of these parameters will change how that looks. And so if I go over here to this float for the multiply and I start messing around with that, let's say I increase it. So now I got like -2, right? Not quite fire looking. I go back down here, -1 or so. It's not great. It's okay. It's not great. So going down to like 0.5 doesn't sort of have a lot of flickering. So I think is that somewhere around like 0.6, 0.7 is pretty good for the way that for the way that I've set this stuff up. So this is around sort of 0.7 here. Changing the scroll speed and the sizes of the Voronoi will change this as well. So there's a lot of, like I said, there's a lot of knobs, a lot of handles that you can mess around with. So that's our UV distortion. This was the whole point. The result of this add was the whole point of doing all of this other stuff back here. It was to get that distortion to apply to our actual texture itself. All right, so there's not a whole lot more to go. Do you have any questions? All right, so I did a thing here called texture packing. The RGB texture here is actually 3 separate textures, but I just packed it all into one and I just put them individually into the RGB channels. So we're going to do the same thing we did over here. We're going to do a split. So I'm going to create a node. It's going to be split. This. And I'm going to plug the RGB. Actually, yeah, it looks we don't actually technically need to do the split, but I'm going to do it anyway. I'm going to take this split and we're going to plug it in here. We could already use the sample 2D to do our split, so I suppose we don't actually need to actually do it. So we have our RGB sort of channels individually. Let's take each one of those channels and let's multiply by a separate color. So I'm going to put a multiply node in like this. And if you change the multiply to 1, here's what that channel looks like. Let me disconnect the distortion here. There's the red channel. So that's one texture that I made. I made that texture. It's just a black and white texture, but I put it into the red channel of the actual final sort of image that I saved out. We do the same thing. I'm going to create another multiply, and I'm going to do the same thing in the green channel. Turns out, and if I change this to 1 here, you can see that little green one here. Turns out we don't actually need the blue channel. I did sort of create it anyway, but we don't actually need it. So here's my 2 multiplies. Let's multiply a color into this. So that's one of the nice things about multiply here. It's got lots of different contexts. All right, so I can create a color node. So let's see, you got to find my color. So here's my input, basic color. And I'm going to plug that into the multiply as well. And then I'm going to change the actual color here. The mode we probably want as HDR. That way we can mess around with some intensity stuff if we want to. So I'm going to change the color. I think in the sort of actual sort of final product for this, I made it sort of a blue color. So, and I don't remember for sure. I think for the green, no, for the red channel, this is going to be sort of a lighter blue, I think is what I sort of go with here. So probably something like this maybe. So I've got this color into the multiply. For the inner one here, we'll create another color node. Do a multiply, set it to HDR, and let's do maybe a darker blue here. We might flip these colors around. It doesn't really matter. These are colors that you can go in and mess around, do whatever you want to with them. So there's my 2 colors. Let's hook up the distortion back to the UV of the texture. And this is what you see. So these are the individual channels, the red and the green channel. So we got to combine them back together. Right, so let's do an add. I'm going to add these 2 back together. Okay, cool. And then I can take this and put this into my color. We're almost done. We don't have any transparency yet. We're going to add that in a second, but that's our result. That's our output. So I'm going to save this asset. I'm going to go back into the game mode, and we can still see the sort of black outline here, the sort of black rest of the quad, but that's what we get. I think I have the colors reversed, but we can go in and mess with it. We can change the colors around. Again, this is only a single quad, but it's because we came up with that distortion, that UV distortion, let us change that simple texture into something that looks a bit more like fire. We still have the transparency to deal with. So we're going to do that in just a second. All right, so back to the shader. Let's mess with the fire here a little bit. Or let's mess with the colors. Let's maybe do like a purple, maybe like a lighter purple or something on the inside, and then maybe a darker like magenta purpley thing on the outside. Maybe something more like that. Again, you mess around. You can use a million things you can do here. All right, so we have the base color. We need the alpha. We need to make sure that anything that's black here is transparent. So we're going to make our own alpha channel. Typically, your alpha channel is grayscale. If something is white, it's opaque. If something is black, it's transparent. And then you have the stuff sort of in between. So for this, to get a nice alpha channel here, I'm going to take this output and essentially I'm going to add together all of the individual channels. So let's do a split. I'm going to make a split, and I'm going to plug this, the output of my add here, so my final version, into the split. And then I'm going to add, on a couple of add nodes, I'm going to add all the channels together. So one more add. I did the 2 channels, and then let's do the last channel with the output of this one. So my add, and I'll move my output here. So I've just taken all the channels and I've just added them all together into one final thing. And that gives me what looks like now the outline and the interior sort of area of where this fire is located. So now if I plug this is my own alpha channel. If I plug this into the alpha, then anywhere where it's white, it'll be opaque, and anywhere where it's black, it'll be transparent. And again, I had to make sure that my graph, if I go to the graph settings up here, make sure that my surface was transparent. So essentially, I just took whatever my output color was going to be, added all the channels, and I got my alpha channel that I need. And plug that into the alpha. So I'm going to say save as, go back to the game view. And there is a stylized fire. Now again, you can mess around with all sorts of the parameters that we have in here. I didn't make any properties using the blackboard. That's something that that I'll mess around with the Diablo shader, because there's a lot of cool stuff that we can do by changing textures and stuff in the second part of the workshop. But the basic idea here is just two noise textures scrolling and a couple of other textures multiplied in to get a distortion. Applying that distorted UV to a texture that's really simple, taking each layer, red, green, and blue, although we didn't really use blue in our sort of output here, but the red and the green channels, applying a different color to them, creating our own alpha, and plugging that all in to the color and the alpha channel of our fragment shader. And that's basically the sort of way to create a stylized, little sort of stylized fire, sort of based on, sort of inspired by the game RiME. So on the slides, I do have a lot of this stuff in there, just talking about the distortion, what you should basically see from this. The way that the texture, that sort of rainbow RGB texture was set up was this wrap mode clamp. I mentioned that the edge pixels were the pixels that were sort of extended down. That's because the wrap mode here is clamp. So you can change how that you can change how it wraps. Unity can like tile it and other stuff as well. But for this particular example, we got to have a clamp so that when we grab other UV stuff from below and bring it above, we're grabbing stuff from this sort of clamped view. So that is one of the things that does have to be changed in the texture itself. All right, and I talked some about the texture packing. So here's all of that stuff, the RGB and doing the split, setting up the different colors. Here I set up a color for that blue channel, but that's not something that we necessarily had to do, but I do show it in here. And then creating the alpha as well by adding them all together. I did put in a final scene that I made a quick couple of assets in Blender, just a column and a sconce. And that is in, we go to the scenes here. That is in the test scene. Let me save this one here. That is in this test scene. So you can sort of see the sconce and the sort of the fire that's in the sconce there based off of the shader. So you can certainly go look at the shaders that specifically the RiME shader from today. You can go look at the finished version of that and sort of see what's going on. But I did create a couple of assets just to show that, yeah, it's it looks good in something like this. If you had some sort of pillar or something, and maybe you had a bunch of these, it's only two quads, or it's only a single quad, so it's only two triangles to render. All the work's being done on the GPU, sure, to do all the scrolling and stuff like that. But as far as resources for creating something like this in your game, you don't have to have a particle system. You don't have to have a bunch of complex simulation stuff happening. It's just two textures scrolling by each other to do a UV distortion. So there's a lot of really cool stuff that you can do with just a very simple shader and a relatively small amount of geometry. So you can certainly feel free to mess around with this. I have the assets in there, so they're all in FBX, so you could open them all up if you want to. All right, so yeah, so that's basically it for today. I was hoping to run just about an hour, so that looks like it's about what it is. So part two is basically creating a two texture shader from Julian Love's VFX of Diablo presentation, and the part three is going to be adjusting the shaders so that they can be used in particle systems. So ultimately, what we're going to get is one of the other scenes that I have here is the main scene, and this one has the sort of fire from the sort of finished version, as well as finished versions of the Diablo ones as well. So these sort of right two, only they use the same shader, they're just using a slightly different particle system and some different textures to go along with them. So this hopefully might be interesting to see as well. So yes, that is all I got. Is there any sort of final questions before we're finished? All right. Well, thank you for coming.